This week at NASA.
Splashdown, splashdown.
The SpaceX Dragon capsule that splashed down Sunday in the Pacific off Mexico's Baja California coast is back on dry land. Its recovery ship returned the spacecraft to San Pedro, California, laden with more than 3/4 of a ton of cargo from the International Space Station. Much of what Dragon brought back was from science experiments conducted on the station that'll benefit us here on Earth, as well as provide critical data about how long-duration spaceflight affects the human body. Not since the Space Shuttle have NASA and its international partners been able to return considerable amounts of research and samples to Earth for analyses.
Sonny, you're going to remove the cover carefully and restrain it on the nadir side.
Back on or outside the ISS, Expedition 33 Commander Sonny Williams of NASA and Flight Engineer Aki Hoshide of the Japan Aerospace Exploration Agency went EVA. The pair bypassed an ammonia leak in one of the station's coolant lines. The leak, which began slowly in 2007, had grown recently. The spacewalk was the 166th on the station and the third since August by Williams and Hoshide. Space Shuttle Endeavour debuted at its temporary display pavilion in a grand opening ceremony hosted by the California Science Center in Los Angeles. Endeavour will make its permanent home at the Samuel Ocean Air and Space Center, now under construction at the CSC. Among those attending the ceremony were astronauts, public officials, and local school children, many of whom it's hoped will be inspired by Endeavour to join our next generation of explorers and scientists. Meanwhile, Atlantis, the last NASA space shuttle to fly in space, also became the last to be officially retired. Beginning at the Kennedy Space Center's Vehicle Assembly Building, Atlantis rolled the 10 miles to the KSC Visitor Complex, where it will go on permanent public display. The orbiter stopped along the route for its retirement ceremony.
America still leads the world in exploration, and we're building on the many fine accomplishments of the Space Shuttle program to take us where we've not gone before, to places where our imagination and our aspiration tells us we can go if we channel the passions that built and launched Atlantis and create a new day.
It is my sincere hope that one day some young boy or girl is going to look at Atlantis and it's going to spark that dream of exploration in space.
NASA retains Atlantis' title. The public can see it at the visitor complex, where a grand opening for Atlantis' new space is planned for next July. Meanwhile, the Kennedy Space Center continues its modernization and refurbishment as the spaceport of the future. The large Space Shuttle-era work platforms have been removed from High Bay 3 of Kennedy's Vehicle Assembly Building. That's part of a center-wide effort to accommodate NASA's Space Launch System and a variety of other spacecraft. When updating is complete, KSC will safely process, assemble, transport, and launch NASA's next generation of rockets and spacecraft. NASA researchers, project managers, and program leads gathered in Huntsville for the first annual review of the Technology Demonstration Missions. TDMs bridge the gap between laboratory development of revolutionary cross-cutting technologies and their practical demonstration in the space environment.
These accomplishments included the Medley experiment that flew in on the Mars Science Laboratory, the Human Exploration Robotic Technology experiment on Space Station that was the Robonaut and the Spears demonstration, and several other accomplishments that we had.
Hi, I'm David Bish, co-investigator on the Kemin instrument on the Mars Science Laboratory, and this is your Curiosity rover update. We've been spending time in an area called Rocknest, and this week we delivered a scoop of a dune to Curiosity. Kemin performs what we call X-ray diffraction measurements on powdered rocks and soil samples. And X-ray diffraction is the best method for telling us what minerals are present in a rock or soil because it's sensitive to the arrangement of atoms in minerals. As the X-rays strike the soil sample, Kemin shows us how mineral crystals distinctively interact with X-rays, and this image shows our first X-ray diffraction results. The diffraction signals appear on the detector as rings that represent the fingerprint of the individual minerals. The rings tell us not only what minerals are present in the soil, but also how abundant they are. The Kemin data provide us with distinctive signatures of the minerals plagioclase feldspar, pyroxenes, and olivines. Peridot is a variety of olivine. Just keep in mind that the olivine in the soil sample is much smaller than these crystals. Roughly half of the soil consists of poorly crystalline material such as volcanic glass. Thus, the Martian soil appears very similar to some weathered basaltic soils that we see on Earth in places like the flanks of Mauna Kea, Hawaii. You can appreciate how revolutionary Kemin is when you consider that instruments of this type on Earth are typically about the size of a double-wide refrigerator, and the Kemin instrument on the Mars Science Laboratory is about the size of a shoebox. Kemin has been modified for use on Earth in places such as Antarctica and the Arctic. It's also been applied for the detection of counterfeit pharmaceuticals around the world, and a modification of the instrument has been used in archaeological studies to help us understand the nature of the surfaces and how we might protect them. In the coming weeks and months, we're excited to measure more X-ray diffraction data on soils and rocks to tell us much more about the geology of Gale Crater. This has been your Curiosity Rover Report. Stay tuned for further updates.
Marshall Space Flight Center astrophysicist Dr. Krista Kovaliotou has been selected by Time magazine as one of the 25 most influential people in space. A NASA astrophysicist since 2004, Kovaliotou is an associated scientist of NASA's SWIFT mission, a member of the New Star Science Team, and co-investigator on the Gamma Ray Burst Monitor, an instrument flying aboard NASA's Fermi Gamma Ray Space Telescope. As for Fermi, astronomers using data from the Gamma Ray Space Telescope have made the most accurate measurement of starlight in the universe and used it to establish the total amount of light from all the stars that have ever shone. Light from stars that have stopped shining still travels throughout the universe, creating a sort of cosmic fog. By measuring average amounts of gamma radiation generated by black hole-fueled galaxies traveling through this fog over the past 9.6 billion years, astronomers can estimate the fog's thickness or density. That comes to 1.4 stars per 100 billion cubic light years, or in other words, the average distance between each star is 4,150 light years.
The Visitor Center at Goddard Space Flight Center is celebrating its newest exhibit, a replica of the Lunar Reconnaissance Orbiter that is circling the Moon. The LRO team at Goddard spent more than a year refurbishing this mechanical prototype to make it look exactly like the spacecraft in orbit, right down to the thermal blankets.
This is a wonderfully exciting day. It's an exhibit that tells the LRO story and NASA's story very well, and we expect that this will be a real attraction for visitors to Goddard.
The interactive exhibit allows visitors to browse the images LRO has captured, learn about the mission, and meet the team. Launched in 2009, LRO has captured some of the most detailed images ever taken of the lunar landscape, providing scientists with critical data about Earth's closest neighbor.
It was really important to let people know about the work that was done here at Goddard, the fascinating things that we're learning about our moon. And it's not a place that, you know, we've been there and that's it. It's a place that we need to continue to explore and learn about because it can tell us so much about our entire solar system.
The information LRO is returning will help scientists identify resources for future exploration and scientific research of the moon.
39 years ago, on November 3, 1973, Mariner 10, the seventh successful launch in the Mariner series of spacecraft, was sent into space at the Cape Canaveral Air Force Station in Florida. Mariner 10 became the first spacecraft to visit Mercury, the first to use the gravitational pull of one planet to reach another, and the first to visit two planets, Mercury and Venus. Mariner 10 measured each planet's environment, atmosphere, surface, and body characteristics. Data from Mariner 10 was used to help plan NASA's current Messenger mission. And that's This Week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.